Hello, this is Professor Ramsey, and I'm beginning the first of a two-part set of videos which cover the Six Sigma overview. And what I would like you to do is download the notes, read them. I will not cover every single aspect of the notes, but in this lecture I will hit the high points. So what we're going to do is give a high-level view of Six Sigma, and many of these topics we'll expand upon as we go through the semester. Okay. Well, first of all, I'll just mention that the foundations of Six Sigma really stem from the work of a man named W. Edwards Deming. And you may not have heard of him. He was a pioneer in the field of quality. He was a statistician, but also he developed what he called his theory of quality management, and the underlying principles of the Six Sigma continuous improvement process stem from Deming. And by the way, Deming, post-World War II, went to Japan and played a key role in the rebuilding of Japanese industry, and he is a well-known figure in Japan, and every year there's an annual Deming Prize, which is a very distinguished prize given to a person who's done the most work in promoting quality. Deming has been dead for a number of years now, lived into his 90s. But his here and there we'll mention him in the course, and I just wanted to point out that Deming is really probably I would call the motivator for what we know as Six Sigma. Okay, and in Six Sigma we basically deal with processes, and I'm going to define process in a very simple way. In fact, in all of our lives we have processes. We just don't think much about them or think formally about them. But essentially we have some inputs, basically. We take those inputs and we do things to them. So maybe the input is some raw materials to make a product. The process is making the product. Okay, so the process may have many steps, and then we have an output. Okay. You know, very simply, we may think of submitting an application for study at UNH. Well, there are inputs. So you fill out the application, you get references and so forth. Then there is an admission process that goes through, and then the output is you are either accepted at UNH, to which UNH provides you a service in the way of education, or you're denied. But those are the two possible outputs. So there are many processes. Just think of it at a high level, and the goal of Six Sigma is to take a process, understand the inputs, and understand how those inputs and the steps in the process contribute to the variation in the output. And again, we'll expand a lot on that as we go through the course. Okay. And when we talk about Six Sigma, there are a few basic assumptions. Number one, all inputs to a process vary. Okay. Also, the steps in the process itself have variation. And also, all processes to some extent have waste. As you'll see later on, Six Sigma focuses on the variation, Lean focuses on waste. Okay? And frankly, the outputs of whatever this process is have all of the effects of all sources of variation. So if you have variation in the input, you have some variation in the steps in the process. This all collectively adds together to cause a great deal of variation in the output. Similarly, if you have waste at many levels of the process, it all sums together to add a great deal of waste to a process, which drives up cost and often reduces quality. And something that's important, and this is where Six Sigma is different than a lot of efforts that people do to improve processes and quality, basically most people focus on the outputs. They want to fix the outputs. They see the product quality isn't very good, the service isn't very good. So instead of trying to go back and figure out what's causing the poor quality or poor service, they think backwards. They think, oh, we got to do something to fix the outputs. So basically in Six Sigma, we think of the behavior of the outputs is nothing more as a result of the behavior of the inputs and the processing steps. So to really improve quality, we don't focus so much on the outputs, we focus on the root causes in the system, and we fix those. So basically, Six Sigma, and often Lean is added to it, is a process by which we're going to try to find the sources of variation in poor quality. We're going to find the sources of waste in a systematic way and eliminate them, so the end result is a much leaner and higher quality product. And the Six Sigma paradigm that we're going to study has been around for over 3 decades now, and it has a lot of longevity, and I can tell you from personal experience, you can achieve a great deal of success in developing a much more efficient and higher quality process, product, or service. Okay. And I mentioned Edwards Deming, but it turns out that what we think of as continuous improvement or quality improvement actually began pre-1920s with a man named Dr. Walter Shewhart, who was a statistician who worked for what was then known as Bell Labs. They made communications equipment. He also worked for the government in munitions factories. And in observing processes, Shewhart noticed that there was a need for some systematic way of continuously improving them. And again, I'm not going to dwell on the details, but he developed something known as the Plan, Do, Study, Act cycle. Well, it turns out that Edwards Deming was actually a disciple of Walter Shewhart. He studied with Shewhart, and he learned a great deal about quality and continuous improvement from Shewhart, and actually improved upon some of Shewhart's ideas and methods. So what's called the Plan, Do, Study, Act cycle was later known as Plan, Do, Check, Act. It's a very simple, structured way to go about trying to improve a process. It is still used today, but you're going to see later in Six Sigma we further developed the PDCA cycle into something called the DMAIC cycle, which is more rigorous and has actually more tools available to it. But the beginnings of what we call the DMAIC cycle, that I'm going to explain in a moment, began with Plan, Do, Check, Act, which really can be attributed to Shewhart and Deming. Okay. So we're going to come back to Walter Shewhart later on, because we are going to use some of the methods he invented at Bell Labs for maintaining and improving quality. So he made some contributions in terms of statistical methods, specifically something we call statistical process control, or SPC, and we'll come back to that later on. Okay. And on the next slide is just a picture of basically Plan, Do, Check, or Plan, Do, Study, Act, or Plan, Do, Check, Act. Okay, I'm not going to really focus on it, but I like to mention it, and occasionally I run into people who are in problem solving refer to the Plan, Do, Check, Act cycle. So I thought it was worth mentioning it to you so that you at least have some idea of what the Plan, Do, Study, Act, or Check, Act cycle is about. Okay. So, as I said, in Six Sigma we actually use something else. In other words, we have a systematic process, but we call it the DMAIC process. And this DMAIC process has been around, say, circa 1995. I think the term was first used, but the methodology, as I've said, in some ways could go all the way back to Shewhart. even pre-1920. Okay, so basically in Six Sigma, again, what is it? Well, basically it's a methodology for continuous improvement of a product, process, or service. Okay? It involves a lot of problem-solving tools and a lot of statistical tools and some other tools we'll mention as we go along. But basically some things I want to mention about it. Number one, it's project-based. So typically in Lean and in Six Sigma, when we find gaps or difficulties in performance, projects are formed that focus on improvement. And typically these projects are worked upon by a team. So usually you'll have a team working on the project. And something that was very important, in fact, I think is one of the keys to the success of Six Sigma itself, it's very much data driven in terms of decision making. So we're going to make a lot of use of data throughout the semester as we work through various case studies and examples and show how we use data to drive our decision making in terms of how to go about improving a process. So we'll use data to help us find the root causes of the quality and sometimes productivity issues related to Lean. So we'll use data. We'll also use data to help us figure out solutions to the problem. And we'll often still use data that once we've improved the process to maintain it. Okay. So there are a lot of tools available as we get through the semester, and you'll see that Six Sigma is really an eclectic blend of many types of problem-solving tools and many types of statistical tools. And therein lies its strength, the breadth and depth of tools available to improvement projects. Okay, so just to give you a very brief history of Six Sigma, where did it begin? Well, I actually first became aware of it in 1990 when I went to a talk by a man named Robert Galvin, who was an engineer. He also happened to be the CEO of Motorola. And in that talk, he mentioned a man named Bill Smith, and he mentioned an initiative they had started called Six Sigma. And it's interesting, because this fellow, Bill Smith, is really the architect of Six Sigma. And it came about because in the 1980s, the Motorola had a communications, well, basically in those days, a pager division. Now, some of you may not have even seen a pager. They're nearly obsolete these days. But they were suffering with a lot of poor quality. They were losing money. They weren't profitable. So Bob Galvin asked Bill Smith, who was a well-known Motorola engineer and had worked with Galvin when Galvin was on his way up through the organization, to look into it. So what he found was that they were losing roughly $900 million a year in the pager division, and he later said across Motorola alone, due to poor quality. In other words, the quality in Motorola was horrible, the pager division being the worst. So what he did, he put together a strategy to reduce the cost of poor quality, which basically means improving quality, and the strategy was be hoped would regain that lost revenue. Well, to get cut to the chase, he developed what later became be known as Six Sigma, although he himself originally didn't call it Six Sigma. This was a term that was applied to it later on. But he initiated the project. Bob Galvin signed on to it and gave him the funding to start the program, have training sessions, and he recruited people to work with him. And Hence, Six Sigma was born somewhere around 1988 or so. Interesting note, Bill Smith himself retired around 1992 and went back to Motorola to work as a consultant, and he tragically died of a heart attack in a Motorola cafeteria. And what Bill Smith didn't know, Six Sigma was about to catch on big time with other corporations, Allied Signal being one of the first to embrace it in a big way. And some of the people that had worked with Bill Smith left Motorola, became consultants, and the early people that became consultants became millionaires. If Bill Smith had survived, he'd have likely become very wealthy, since he was sort of the Six Sigma guru. But that was the origins of Six Sigma, and it all started with one man named Bill Smith, who'd mapped out a strategy to improve quality in Motorola, and his program was enormously successful. I should add, eventually, around 1995, General Electric embraced Six Sigma, and that's when Six Sigma really burst on the scene as a major strategy for business and process improvement. So I just mentioned that because many people wonder where Six Sigma came from. It originated with a man named Bill Smith at Motorola in the late 1980s. Okay, and you wonder about the term Six Sigma. Well, the sigma comes from the fact that in statistics we use the Greek letter sigma to represent the variation in a variable, something we measure. Like we could be measuring the variation in a product characteristic, and we use sigma as a theoretical representation of variation. So I'm not going to dwell on it, but that's where the sigma came from. And the six actually comes from the fact that for a process, okay, to be of high quality, the specification limits should be 6 sigmas. And another word for sigma, by the way, is standard deviation. So I'll talk about that later for those who have no background in statistics, so don't worry about it. But in other words, from the process mean, it should be 6 standard deviations to a specification limit. Okay. Later I'm going to illustrate this, but I need to supply more background for it to make complete sense to you, but that's what Six Sigma comes from. And furthermore, at Motorola and some organizations, they developed what they called the Sigma quality level. I'm not going to use it to any extent this semester. At one time, people measured the quality of a process, which could be a product or a service, in terms of what they called the Sigma quality level. It's falling into disuse. It's a nice concept, but it's something very hard to measure in practice. So the higher the quality level, the higher the Sigma quality level. So high Sigma quality level means that you have very high quality and errors or defects in a process or service are very rare. In fact, what they called Six Sigma quality level corresponded to 3.4 million defects or errors per million opportunities. Okay. So if you were at a Six Sigma quality level, basically you had a process in which no more than 3.4 defects or errors would occur per million opportunities for them to occur. That's a very stringent criteria, and it is very difficult to get a process to that level. But if you are at a Six Sigma quality level, then errors or defects occur very rarely. Okay. Now, I'll come back to that later on in a future section, but I just want to introduce the term Six Sigma, where it comes from, and what is meant by a Six Sigma quality level. Okay. Now, what about lean? Lean comes from a very different origin. But as you're going to see, Lean and Six Sigma are really, for the most part, used together these days. What's called Lean originally was called the Toyota Production System. This was pioneered by Toyota and by a very senior engineer named Taiichi Ono. And he laid out the principles of how to have a lean and what he would call flowing manufacturing operation. What's interesting, Ono himself in the 1950s said, everything I learned about lean, I learned from reading a book by Henry Ford. Henry Ford, again, the original Henry Ford was the founder of the Ford Motor Company, and he pioneered modern manufacturing methods. And he wrote a book on manufacturing decades ago, back I believe in the 1920s. Ono found a copy of the book and read it, and he said everything you want to know about running a lean, smoothly flowing process you could learn from Henry Ford. And he expressed his surprise that in the United States most people had never heard of the book or bothered to read it. And Henry Ford, and we won't get into it beyond this point, was a real pioneer. And so a lot of the ideas in lean go all the way back pre-1920. And just like many of the ideas in Six Sigma also go back pre-1920 with Walter Shewhart. So a lot of these ideas are not new, but what is new is the tools we have available to implement Lean and Six Sigma, tools that weren't in some cases available even 10 years ago, thanks to modern computing power and software applications. So basically, as I said, Lean focuses on waste. What are the things in a process that don't add any value? These are activities people are doing. Essentially, the person purchasing the product or the service would never pay for this activity if they knew it was going on. And again, I'm going to ask you to read the book Lean Thinking by Womack and Jones, and in there they'll lay this all out for you in a very simple to read and well-organized manner. But typical ideas of manufacturing waste, overproduction. What we'll learn later on that the typical American approach to production was what we call a push system, where the manufacturer pushed as much product through a process as they could, regardless of customer demand. So overproduction leads to a great deal of waste, producing stuff for which there may not even be a customer. Also, waiting, having people standing around waiting for something to happen. Transportation. It is amazing the amount of unnecessary movement that occurs in goods and services in terms of manufacturing, even producing a service. Like in a service organization, for instance, I mentioned submitting an application. Well, I don't really know all the steps it goes through, but it's entirely possible, especially pre-electronic submittals, that paper were passed all over the place. So there are many types of waste. Again, you'll read about many of them in Lean Thinking. And in Transactional Process, similar idea. You have lots and lots of things that people do that are just absolutely unnecessary. The key here is to remember Six Sigma focuses on sources of poor quality or variation and eliminating them. Lean focuses on sources of waste and eliminating them, and often the two go hand in hand. So in improving quality, we often do it by eliminating waste and eliminating the sources of the poor quality. Okay. Now I mentioned the DMAIC cycle, and I did want to at least explain it to you because more or less the course is going to be structured around it. So there are basically 5 steps to what's called the DMAIC process. Some people call it the DMAIC cycle. And I'm going to explain each one of them, but DMAIC is an acronym for Define, Measure, Analyze, Improve, and Control. And then I'll briefly describe the activities that go on at each phase. Okay. In fact, the DMAIC cycle itself is just a nice way of organizing your work and making sure that you do all of the things that need to be done to ensure a successful project. Well, basically, when we begin a project, well, there has to have been somewhere some recognition that there's a problem that needs to be addressed. We won't talk in great depth about this, but in many organizations there are management teams, and they put together a portfolio of potential projects based upon perceived gaps in quality or productivity, areas where they may be getting a lot of complaints from customers and consumers. So basically at the start of a project, there has to be a recognition of that there is some opportunity we want to address. The define phase means exactly that. Define the project. And in another section, I'm going to talk in depth about what's called a project charter. This is important. This will define the project, define exactly what you will do and what you will deliver. Okay. One of the great problems with many projects, and this isn't just Six Sigma, is they're so poorly defined and vague, they have virtually no chance of really succeeding. In fact, I would say, in my experience with Six Sigma, if you get the define phase done properly, you've properly identified the project, you're probably 40 to 50% on your way to success. So this define phase is important, and traditionally people have jumped right over this because we tend as people to be impatient. We're biased for action, and the define phase is a lot of work, and people don't want to be bothered with it. They just want to run out and start doing things. Well, what usually happens, they start doing a lot of things that in the end aren't effective at solving the problem because they never backed up and defined it to begin with. So basically, in the define phase, we define the project. This will be represented by a project charter. We define the process that we're studying, and we start identifying key inputs and outputs. And as I'll explain later, if data exists, we may begin exploring data for potential cause and effect relationships. The second stage, and this is the classic DMAIC, is often called the measure phase. And historically, in these projects, often data didn't exist. So teams would have to put together data collection plans and collect data just to understand what the process is doing. Basically, if you can't measure the performance of a process, your chances of improving it are quite limited to perhaps nil. So we're going to really stress the importance of measuring the inputs and the outputs and the various intermediate steps of a process. We need to measure our performance. We also have to make sure that measurement systems are evaluated and capable. Sometimes improvement projects go nowhere simply because the measurements being used are incapable. As an example of that, if you're collecting data or you have historical data in a database, if the quality of that data is poor, then basically it's useless in terms of trying to understand the process and bring about improvements. And it's also important, if you're going to improve a process, you need to have a baseline. What is the current state of the process? So in the measure phase, one of the key activities is baseline current performance. Okay. This again is often something that isn't done or done carefully. So people do a project, they believe they've made improvements, but given they had no original measurement of performance, they can't really clearly demonstrate that they had done any good. So this is the measure phase. The analyze phase in classic Six Sigma, and we're going to deviate a bit from this. The DMAIC cycle is getting a bit out of date because of all the data we have available to us these days. You hear the terms big data. Well, there is an awful lot of data. It's a bit beyond our scope to get into the field of big data, but it's inescapable in doing Six Sigma that there are lots of sources of data. So traditionally, that a lot of data didn't exist, so you collected it and you analyzed it. Well, today we may start doing some of the data analysis right in the define and measure phase because there's already so much data. But basically in the analyze phase, we've collected data, we analyze it using various statistical methods. We look for root causes, and then we identify opportunities for improvement. Okay, and then we move into the improve phase. This is where we again use a lot of statistical methods. We've identified at this point the root causes of the problems, and we start looking for solutions. So in the improve phase, we come up with solutions, and we'll talk later about how we do that. We test that the solutions are workable and that they should achieve their results. And then we develop an implementation plan. You don't just run out and make changes. You have to follow a structured approach to implementation. And then finally, and this is the key, the solutions are implemented. Well, historically, at this point, a team would implement a solution, hold a self-congratulatory party, and go off, go their separate ways. And the solutions they implemented often have completely been undone, even within hours, maybe weeks. So they recognized this in the Six Sigma development, and they added what was called the control phase. So we implement improvements, but the team doesn't disband. They still have primary responsibility for process performance. So you continue to monitor the process behavior. Again, we'll have a lot more detail later on how we monitor it. And we make sure that the gains are achieved. If we find after some length of time, usually the control phase can be 3 to 6 months. If we don't see the improvement, then the team has to decide, do we circle back and see if we've missed something or if something's changed? But if the process is running as it has been implemented and you are seeing the improvements, then at the end of the control phase, the process is typically turned over to what we would call the process owners or stakeholders. At that point, the team would then celebrate success and move on. Or if they didn't achieve success, they'd have to come back, have a talk with management, and decide if it's worth going back and seeing if there's something else that can be done. Most of the time, these projects achieve success, provided people have clearly defined them and properly worked on them, followed basically the DMAIC cycle. Your chances of success are quite good. Okay. I won't talk about it right now, but there is also another flavor of Six Sigma called Design for Six Sigma. The DMAIC process itself is really geared to continuously improving a process, a product, or a service that already exists. Okay. So it's not really something you would use if you're designing or redesigning. Okay. So there are other forms of Six Sigma called Design for Six Sigma, and if we have time at the end of the semester, I'm going to come back to this topic, but there are analogs of the DMAIC cycle, with probably DMAIC being the most common, and I'm not really going to get into it at this time, but you would do the design for Six Sigma. One, if from the beginning you were designing a new product or process, or you've decided the only way you can improve the process or product is to redesign it. So I've seen teams trying to improve the quality of a product, and somewhere along the line, following the DMAIC cycle, they suddenly realize there's no way to improve this, it's got to be redesigned. So at that point, management would have to decide if they want to kick off a redesign team. Okay? And often that will be an economic decision. Okay. So basically, I'm going to move through some of this. And I mentioned that Six Sigma is used both for manufacturing, and it's also used for what we call transactional. So let me basically explain the difference between manufacturing and transactional. It's very simple. If the output of the process could be dropped on your foot, we would call it manufacturing. If it cannot be dropped on your foot, we'll call it transactional. Okay. I know that sounds kind of foolish, but that actually comes from MIT. And so in the transactional Six Sigma projects, we're looking at non-manufacturing aspects of an organization. Okay. And both types of projects are very, very common. Okay. For instance, one you'll see a lot of in call centers, they have abandon rate. What that typically means, the system is so overloaded and they're answering the phone so slowly, the system will start kicking people off. Well, obviously that is not a good idea. So there's a lot of Six Sigma projects that are focused on how to improve that abandon rate. In other words, how do we facilitate answering the calls more efficiently? Also in Six Sigma, I should point out the people who worked on this originally at Motorola, a number of them were karate buffs. Because of that, some of the karate terminology made its way into Six Sigma, and I don't necessarily like it, but the terminology has stuck. It's commonly used, so I think I'm just going to live with it. So in a Six Sigma program, we typically have different types of people who take part in it. They have different roles. Sometimes we just call them players. One are green belts. So this basically is more or less what we'll call a green belt course. And a green belt typically works in Six Sigma on a part-time basis, typically have up to 80 hours of training, potentially. By the way, in Six Sigma itself, there is no standardization of exactly what is a Six Sigma curriculum. And I don't think there really needs to be. This course will put you on the high end of what's called green belt training. So even doing this for a company, it's typically 80 hours of actual training. That's contact time. And basically we won't even do 80 hours, but we're going to do a lot of more than enough to say you've had sufficient green belt training. Okay. Sometimes there are also what are called yellow belts. There are white belts, green belts, who knows. Again, it comes from karate. Yellow belts basically are people who have some training in Six Sigma, okay, but don't, basically they're support people. They don't take direct roles in Six Sigma projects, but they have enough training to understand Lean Six Sigma concepts and understand, for instance, DMAIC and how it works so that they can support a project when called upon. Probably one of the big players that you most often hear about are called black belts. Well, these people who completed up to 20 full days of training, they typically have completed at least 2 significant projects. Again, this is not standardized. It depends on the organizations involved. So I typically require 20 days. That involves a lot of training in statistics. That also involves some mentoring as part of those 20 days. And black belts are typically the people who really lead the projects, and they're really the people who drive the Six Sigma program. So black belts are key, have key roles in organizations, and really good black belts, and especially if they also have really good lean skills, are in very high demand. And then there is something called a master black belt. Usually these are people who have worked as green belts and then may become black belts. They gain a lot of experience, and they really are considered more or less gurus. They're often highly respected in organizations and often act as mentors and guides to black belts. So master black belt is considered a high level. And then finally, you'll sometimes hear me talk about sponsors and champions. Well, when you have these projects that you work on, typically you need someone to sponsor it. Typically somebody high enough in management or administration that they can drive the project, see that you get the resources you need, and there are also champions. Sometimes the sponsor and the champion are the same person, sometimes they're not. So champions can be people who champion the Six Sigma program, and they may have any number of sponsors reporting to them, and the sponsor is typically, again, somebody who sponsors the project, and the black belts and green belts would typically report to the sponsor, and that sponsor in the end is responsible for the success of the project. Okay. So these are some Six Sigma tools. I'm only going to mention SPC briefly because it comes up early on, or statistical process control. Again, this was invented by Schuhart, actually pre-1920. He began with it. And it's a way of measuring performance in a process. And again, I use process in a very general way. And we use what's called control charting to monitor the process. Again, you'll see more of this in the next few sections, but I just wanted to introduce the idea. We'll also talk about measurement systems analysis. Never assume the measurements that are available or that the quality of the data is acceptable. It needs to be evaluated. Okay. The rest of this I'm going to thumb through because we're going to cover all of these later on. Okay. And also we're going to talk about what's called process mapping, and a part of that in Lean is something called value stream mapping, and I've actually asked you to watch a YouTube video about it. These are basically, this is a fundamental Lean tool. And it can be very effective in finding, for instance, bottlenecks in processes or even places where problems are frequently occurring. Okay, and that ends part one. In part two, I'm going to talk about a case, excuse me, a case study from the Visual Six Sigma book. So that will be part two of the overview. And I will ask you to read chapter 4 of the Visual Six Sigma book, but we don't have to worry about that tonight.